In the last video, we looked at trig ratio basics. So we looked at sine and cosine and tangent, and we defined each of them. So we said sine of an angle, and an unknown angle, remember, is theta. So sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tan of our angle is opposite over adjacent. And we labeled our triangle to make sure we were all labeling it in the same way. Sine and cosine and tangent are useful because they can help us find an unknown side or an unknown angle of a right-angled triangle. So let's start with unknown sides first. If we look at this example here, we know an angle, 40 degrees. We have a right-angled triangle, so we can find this missing side length. Here's our right angle, so this we know is our hypotenuse. This is the angle we care about, right? We know that it's 40 degrees. So that means that this side here is opposite and this side here is adjacent. So based on the angle that we know and looking for this side length, we know we need to compare opposite to hypotenuse, which means we need to use sine. So sine of theta is opposite over hypotenuse, and we can fill in what we know. We know theta is 40 degrees. So sine of 40 degrees is opposite, which is x, over hypotenuse, which is 12. Now, if we do some cross multiplication, remember we can write this as sine of 40 over 1. So now we have our fractions. So 12 times the sine of 40 equals 1 times x. And now we can solve this in our calculator. 12 times the sine of 40 is 7.7135. Remember that your calculator needs to be in degree mode to solve this. So similarly, we can find the unknown sides of these three triangles. Here's 50 degrees. This is our hypotenuse, opposite, adjacent. So again, we're comparing opposite and hypotenuse, but this time we're looking for our hypotenuse and we know the opposite. So let's see how that is a little bit different. Again, we have sine of theta is opposite over hypotenuse. Theta is 50 degrees. So the sine of 50 is opposite, which is 15, over our hypotenuse, which is x. We'll do some cross multiplication again. So now we have x times the sine of 50 is 15. So to get x, we'll say x is 15 divided by the sine of 50. So instead of multiplying, like we did up in this top example, we're dividing. And if we do 15 divided by the sine of 50, we'll get x equals 19.5811. If we look at these other two, instead of sine, we'll be using cosine and tangent. So let's take a look just to make sure we're all on the same page. Here's our right angle, here's our hypotenuse, here's the angle we're interested in. This is our opposite side, this is our adjacent side. So in this case, we're comparing adjacent and hypotenuse. So that means we need to use cosine. So cosine of theta is adjacent over hypotenuse. So cosine of 55, adjacent is x, hypotenuse is 6. So 6 times cosine of 55 is x. And if we do that calculation on our calculators, we'll get that x is 3.4415. I'm going to erase these two to give us the third one, just so we don't have to be squished in here. Here comes our last example. Here's the angle we care about. Here's our right angle, so this is hypotenuse. This is opposite. This is adjacent. So now we're comparing adjacent and opposite, and remember tangent is opposite over adjacent. So we're going to use tangent. Tan theta is opposite over adjacent. And let's fill in what we know. We know that theta is 25. So tan of 25 equals opposite, which is x, over adjacent, which is 7. So similarly, we'll do some cross multiplication. 7 times tan of 25 is x. And if we do that calculation, we'll get x is 3.2642. Okay. Sine, cosine, and tangent are buttons on your calculator, right? You should see a button that looks like this, a button that looks like this, and a button that looks like this. So if you're having trouble plugging this into your calculator, like this last one, 7 times tan of 25, I would just type in 7, and then your multiplication button, and then your tangent button, and then 25 equals. Okay, so hopefully that's making some sense. That's all you need to do to find a missing side. So let's move on and look at finding a missing angle. So just like we were finding missing sides, we can use sine, cosine, and tangent to find missing angles. So here's theta. Let's start by labeling our triangle. Hypotenuse, opposite, adjacent. So hopefully by now you can figure out quite quickly that we need to use sine, right? We care about this angle, opposite over hypotenuse. So sine of theta is opposite, which is 8, over hypotenuse, which is 10. Now, remember if we have an algebraic equation, let's say we have x plus 2 equals 8. Our goal is to get the x by itself, right? To get the variable all by itself. So to do that, we would subtract 2 from both sides, because the opposite of addition is subtraction, and we would end up with x equals 6. Similarly, we want to get rid of this sine, right? We want theta all by itself. So the opposite of sine is something called inverse sine, and it looks like this. It's this little button right here on your calculator. Sine, and then it looks like it has a -1 as an exponent. It's not an exponent, but that's what the button on your calculator looks like. So to get rid of this, to get theta all by itself, we're going to take the inverse sine of both sides. And if we take the inverse sine of this side, the inverse sine of the sine of theta is just theta. And then we'll do the inverse sine of 8 over 10. Okay, so on your calculator, the inverse sine is usually a second function button or a shift button. And so you'd use it the same way you used your sine button. Push the inverse sine button, and then in brackets 8 over 10. And if you do that, you should find that sine is 53.1301 degrees. We can use inverse cos and inverse tan the exact same way. So here's theta. Here's our hypotenuse. Opposite, adjacent. So we're comparing adjacent and hypotenuse, which means we need to be using cosine. So cosine of theta is adjacent, which is 6, over hypotenuse, 12. You can reduce this fraction or turn it into a decimal if you want to. I tend to leave the fractions as they are. We'll take the inverse cos of both sides. So theta equals inverse cos of 6 over 12. And when you do that, you should get that theta equals 60 degrees. Finally, let's look at an example with tangent. Here's our theta, opposite, this is hypotenuse, here's adjacent. So tan theta is opposite over adjacent, so 40 over 60. So theta equals the inverse tan of 40 over 60. And if you do that calculation, you'll get that theta equals 33.6901 degrees. So in this video, we looked at finding a missing angle or finding a missing side using sine, cosine, or tangent, remembering that we need to have right-angled triangles in order to do that. If we don't have right-angled triangles, we're going to have to use sine law or cosine law, and those will be explored in the next 2 videos.